All right, looking at answers for review for quiz 12. Starting with number 1, average value of f of x squared minus 2x between 1 and 4. So we're going to start with 1 over b minus a, 1 over 4 minus 1. We're going to integrate from 1 to 4, and then we're integrating x squared minus 2x dx. So I get 1/3 out front. I integrate x squared, that gives me x cubed with a 1/3. Integrate 2x, that gives me x squared. And we're going to evaluate from 1 to 4. Plug in 4. So 4 cubed is 64. 4 squared is 16. Plug in 1. 1/3 minus 1. So 64 minus 1/3 gives me 63 over 3. Negative 16, that's going to end up being a plus 1, so that's minus 15. 63 divided by 3 is 21. 21 minus 15 is 6, and 6 divided by 3 is 2. So 2 is my average value. Again, make sure we understand that average value is an average y value. Next one. And a lot of us were not doing number 2 right, or we at least weren't starting off right. Find the values guaranteed, or find the value of c guaranteed by the MVT for integrals for g of x on the interval from -2 to 2. Remember, MVT for integrals guarantees that there is a y value that is equal to the average y value. So that means I have to find the average y value first. So 1 over 2 minus a -2. Integrate from -2 to 2. I've got 1 minus x squared. So I've got to find the average value first. So 1/4. I have x minus 1/3 x cubed from -2 to 2. 1/4, plug in 2, so that's 2 minus 8/3 minus, plug in -2, so that's -2 plus 8/3. Alright, 2 plus 2 is 4, -8/3 minus 8/3 is -16/3. 3 times 4 gives me 12, 12 minus 16 gives me -4 over 3, times the 1/4, so that gives me -1/3 as my average value. The MVT for integrals guarantees that there is a y value that is equal to this average value. So now I take this y value and set it equal to my function. Set that equal to my function. So my function is 1 minus x squared. And I need to solve for x squared. So I'm going to switch these two. So x squared equals 1 plus 1/3. 1 plus 1/3 is 4/3. Take the square root. And make sure both of those are in my interval. My interval is -2 to 2. That fits in my interval. So those are the x values, or the c values, guaranteed by the MVT for integrals. Next one. Next one is second fundamental theorem of calculus. This one we better not miss. So anytime you see that derivative, anytime you see the derivative of an integral, that means we're dealing with the second fundamental theorem of calculus, which says plug in your variable. So we plug in our variable, which gives me that, multiply by the derivative of what you're plugging in. So the derivative of x squared is 2x, and since the variable is in the bottom, that means I also need a negative. So that is my best looking answer. Do not miss the second fundamental theorem of calculus problem. Easy stuff. 4. On 4, we're just finding a function value. So I want to find f of 3. The y value they gave me is 4. That y value is attached to the x value of 1. So the x value that goes with this goes here. The x value that I'm looking for goes here. And we put 4 minus 3x squared dx on the inside. And then all I have to do is work it out. So 4 stays there. Integrate 4, I get 4x. Integrate this, I get 3 over x. We're going from 1 to 3. Plug in 3. 4 times 3 is 12. Plug in 3 there, that's 3 over 3, so that makes 1. Plug in 1, so that's 4. Plug in 1, and that's 3. So 12 plus 1 is 13. This is 7, so that's minus 7. So this gives me 6. 6 plus 4 gives me 10. So that means f of 3 equals 10. Next problem. So let's go to the smartboard on this one. Alright, the figure above shows the graph of f prime, which is the derivative of f between 0 and 2. What is the value of x at which the absolute minimum of f occurs? So we know absolute minimum occur at the endpoints and the critical points. So my endpoints are 0 and 2, and my critical point is 1. So I want to know f of 0, f of 1, f of 2. And we are wanting a minimum, so I want to know which one of these two is the smallest. And we're not going to be able to get any actual values for here. We're just going to have to do some comparison here. So we want to compare 0 and we want to compare 1. Okay, whatever 0 is, when I go to 1, since I have a positive area, then that means that 1 is going to be larger than 0. Okay, so 1 is going to be larger than 0. So I want a minimum, so that means 1 cannot be my minimum. Then we go from 1 to 2. We have a bunch of negative area here. And since this area is larger than this area, then that means that 2 is going to be smaller than 0. Okay? So whatever 0 is, I'm going to increase a little bit because of this, but then I'm going to decrease a lot because of that. So that means 2 is going to be smaller than 0. So my answer is 2. We will stay over here on the smartboard since we've got a graph. Graph of f consisting of 3 line segments is shown. On the right, let g of x equal that integral. It's probably a good idea anytime you have a function that's defined by an integral to go ahead and take the derivative of both of these. So the derivative of g of x is g prime, and the derivative of this integral is f of x. So anytime you have a function and it's defined by an integral, go ahead and take the derivative because you're more than likely going to use that later on down in the problem. So I need g of 3, I need g of -1, I need g of 5. So notice we're starting at 1. So when I find g of 3, I need the area from 1 to 3. So I come over here, I need the area from 1 to 3. So this is going to be 1. This is going to be a half. Notice both of them are below the x-axis. So that's a -1 and a -1/2. So that means g of 3 is going to be -1.5. g of -1. So I plug that in. Notice that this is backwards. So that means whatever I get, I need the opposite sign of it. So between -1 and 1. Between -1 and 1, I have an area of 1 and an area of 1. That's 2. It would normally be negative because it's below the x-axis, but because since this is switched, that means I change the sign. So that means g of -1 is equal to 2. And then 5, plug in 5, I need the area from 1 to 5. So area from 1 to 5. I already know this is -1.5, so then I just need the area of this. This is 2 by 2. So 1/2 times 2 times 2 is going to give me 2. So -1.5 plus 2 gives me 0.5. Alright, absolute minimum. Absolute minimum. So we want to look at the endpoints and the critical points. So endpoint, -1, critical point is 3, endpoint is 9. So I've just got 3 things to look at here. G of -1 we already said was 2. G of 3 we already said was -1.5. So that means I need to figure out what 9 is. So the area from 1 to 9. So I already know from 1 to 5 we said was 0.5. So I just need to figure out what this is here. 1, 2, 3, 4 times 2. So 1/2 times 2 times 4 is going to give me 4. So I take this plus 4 means that that's going to be 4.5. I'm looking for the absolute minimum value. There's my smallest minimum. So I'm going to say absolute minimum is -1.5 at x equals 3. Okay, remember, when you're doing absolute extrema, you do not have to write anything down. Your work is your justification on that. Points of inflection, as we talked about at the end of class, points of inflection occur where the derivative changes from increasing to decreasing or vice versa. Okay, so we might think something's going on here at 2, but nothing's going on at 2 because I'm not increasing or decreasing here. So my only point of inflection is going to be at 5. I'm increasing and then decreasing. So I'm going to say POI at x equals 5 because f changes from increasing to decreasing. And that would be my answer for C. Next one. Alright, we'll stay over here on the smart board on number 7 because number 7 is pretty easy. We want to find f of 2. They gave me this. They told me the derivative is that. So if I want to find f of 2, that's going to be 7 plus, since 3 goes with 7, 3's got to be down here. 2 is what I'm looking for, so 2 goes there. Put my function inside. And then all I have to do is plug that in to my calculator. Remember, to get the integral, you press shift and then plus. That'll bring up the integral, and then you just fill out everything. Press enter, and it gives you D as the answer. So there's that. All right, let's move back over here for number 8. This is one we haven't talked about, but you're sharp enough to figure this out. From x plus 1 when x is less than 0, and cosine when x is greater than 0. We want to integrate from -1 to pi over 2. So that means we have to split this up into 2 of them since this function breaks up at 0. So I need an integral that goes from -1 to 0, and then I need another integral that goes from 0 to pi over 2. So it says x less than 0, we use x plus 1. This is less than 0, so we use x plus 1. And greater than 0, we want to use cosine. So this side is greater than 0. So it's just a matter of splitting it up and making sure the correct function is in the right spot. Integrate from -1 to 0. I plug in 0. I'm going to get 0. I plug in -1. I get 1/2 minus 1. So this is going to give me -1/2, and then it's going to turn into a positive 1/2. Cosine, integrate cosine, I get sine from 0 to pi over 2. Plug in pi over 2. Plug in 0. We should know both of these pretty easy. We should know sine of pi over 2 is 1, and we should know sine of 0 is 0. Put these two together, and we get a value of 1.5. All right, number 9, back over to the smart board. All right, we have a table of values for f prime we know that f of 0 is 100. We want to estimate f of 6 using a right Riemann sum. So that means f of 6 is going to be 100 plus the integral from 0 to 6 of f prime of x. And then it wants me to figure this out using a right Riemann sum. So I've got the 100 and a right Riemann sum. So the difference between those two is 2, and then my right number is 18. The difference between the next two is also 2. My right number is 23. And the last difference is 2. And my right number is 25. And when we do that, we end up with 232. I'm not going to take the time to go through that. You guys can do that. So we end up with 232. Alright, the number 10 is one of my favorite problems. They tell me f of 3 is 4. We want to sketch the graph of f, given the fact that we have f prime. So again, we can find each one of these critical points and endpoints. We can find that. So, first thing we can find is 0. So we need from 3 to 0. Notice that's backwards. So since it's backwards, we're going to switch the signs. So from 0 to 3, it would normally be negative 3, but since I'm going backwards, it's going to be a positive 3. Okay, and let me go ahead and show my work a little bit. So we have 3 to 0 of f prime of x. Okay, we want 0 to 3. Okay, so that's where the negative comes from. This right here is a negative 3. Another negative turns it into 3. So this is equal to 3. All right, the next thing we can find is 5. So 3 to 5 of f prime of x dx. That area is 5. Oh, I forgot something. I forgot to use the fact that f of 3 was 4. So that means I need to add 4 to this 3. So that means that is actually 7. So on this one, this is 5. I started at 4. So that means that's going to be 9. Okay, I'll get it right on the next one. And then the last thing I can find is 8. So f of 8 is going to be 4 plus the integral from 3 to 8 of f prime of x. So we're going to start off with 4. We're going to add 5, which is 9, and then we're going to subtract 4, which puts me at 5. So they gave me f of 3 is 4. I know f of 8 is 5. I know f of 5 is 9. And I know f of 0 is 7. So my biggest y value is 9, so I want to go up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, f of 0 is 7, so that's going to be here. F of 5 is 9, so 1, 2, 3, 4, 5 is 9. So that's up there. F of 8 is 5, here's 8. 1, 2, 3, 4, 5, that's going to be there. And f of 3 is 4. 1, 2, 3, 4. So then the next thing I want to do is find my points of inflection. As we talked about earlier, I'm going to have a point of inflection here, here, and here. So I put those dots in there. So this point of inflection looks like it happens at 2. So I'm going to go to 2, and then I'm going to go up until I'm in line here. So up, I got a point of inflection about there. This one we're going to call it here. So I'm going to put it there, and then this one right there. So there's my points of inflection. Now we look at concavity. My derivative is decreasing here, so that means I'm concave down on that first section. So this first section is concave down. Then we're increasing from here to there, so I'm concave, or sorry, from here to there, so I'm concave up. I continue to increase from here to there, I'm still concave up. Then I decrease from here to there, concave down, decrease from here to there, still concave down, and then we increase again, which means I'm concave up. So that's what we're looking for on that problem. I'm hoping you guys impress me tomorrow and get that one right. All right. Number 11 is just wanting to know, do you understand the fundamental theorem of calculus? It's telling me that G prime is equal to F. So that means if I integrate F, I should get G. So if G prime equals F, if I integrate F, I should get G. Okay? And we're going from 2 to 3 right there. So if I integrate F, I get G. And we're going from 2 to 3. Plug in the top one first. Plug in the bottom one. I get G of 3 minus G of 2. So my answer is C. Number 5. Again, this is one you just set up and plug in your calculator. Let the calculator do the work. So we have f of x here. And it says G is an antiderivative of F, so that means if I integrate F, I get G. They tell me G of 3 is 5, and they want me to find G of 1. So G of 1 is going to be 5 plus the integral. 3 goes with the 5, so 3 needs to be down here. 1 is what I'm looking for, and then put my function inside. Okay, and then punch it in the calculator. It does not matter if these are not in the correct order if you're punching in the calculator. If you're doing it by hand, then we want to go ahead and switch it. But I'm using a calculator, so I go ahead and punch it in, and when you punch it in, you get B as your answer. Alright, 13 is a fun problem. It gives me this integral is equal to 17. I just want to know what is this piece. So all we have to do is expand all that out and then solve for this, and that'll tell me what it's equal to. So I'm going to separate these two right here because of that plus, and I'm going to pull this 2 out. And this whole thing is equal to 17 as it says. Okay, here I'm integrating just the numbers, so we should be good at that. Take the difference here, which is 3, and multiply, so this thing right here is equal to 9. Now it's just a matter of getting this by itself. So we're going to subtract the 9 over. So if I subtract the 9, that gives me the 8. And then I got to divide by 2. Which gives me 4, or sorry, divide by 2 and I get 4. So 8 divided by 2, I end up with 4, so that means this right here is equal to 4. Okay, again on 14, we're taking the derivative of an integral, so we have another second fundamental theorem of calculus, so it should be easy. Step 1, plug in, so 1 over 1 plus the square root of x squared. That's step 1. Step 2 is to multiply by the derivative. The derivative of the square root of x is 1 over 2 times the square root of x. So I've got to figure out which one of these matches. Right here, if I square this, it's just going to give me 1 plus x. So I have a 1 on top, I have a 1 plus x, and then I have the 2 square root of x. And I look for the one that matches. A is going to be my answer. Easy stuff. And 1, 2, 3, 4. All right. That looks like everything on the review. Make sure you take the time to go over this video. Make sure you know how to do everything. Don't go into the quiz not knowing how to do everything. You should know how to do everything. We did it on a homework assignment. We did a quiz review. You have the answers to all your assignments, and you have the videos to all your assignments. Put the effort in and do a good job.